Bismillahirrahmanirrahim. I am Paradisa, the lead author of this publication. On this occasion, I will present our research titles, Enhancing Medical Expenditure Prediction Using Machine Learning on Claims Data for Better Healthcare Cost Management. Prospective disease group-based payment is a reimbursement framework used in many countries, employing case grouping system like the APRDRG code in the US and INA-CBG code in Indonesia's BPJS. This categorization helps health insurance providers manage claims and standardize payment by grouping patients based on diagnosis and procedures. Each category will have a code that will be input into the claim system, determining the reimbursement amount that the hospital will receive. But this system has several weaknesses. However, advancement in healthcare data and machine learning offer new opportunities for predicting health costs and risk adjustment. On the other hand, claims data, which is a type of electronic medical record primarily used for billing, encompasses a range of information beyond diagnosis codes, such as demographic and facility usage, that can enhance cost prediction. Machine learning holds significant potential to leverage this richer data without solely relying on manual categorization. Therefore, in this study, we will assess machine learning feasibility in regression analysis using comprehensive claims data to better predict healthcare costs, improving financing accuracy, and reducing losses in health insurance system. For this purpose, we are utilizing two algorithms that are recognized for their reliability in regression, that is XGBoost and random forest. Additionally, we are employing linear regression as a benchmark to compare the result generated by these two algorithms. And here is the methodology of our research. We begin with a dataset of inpatient claims data. The first step was encoding, where we converted all non-numerical variables into numerical form to prepare the data for regression analysis. Following this, we conducted feature selection to determine which variables significantly contribute to healthcare costs, and the selected variables serve as predictors in our regression model. For the regression analysis, we employed three algorithms: linear regression, random forest, and XGBoost. Linear regression was used as a baseline to capture linear relationship. Random forest was applied to address nonlinear patterns and interaction among variables. Finally, XGBoost was included as a state-of-the-art ensemble method, recognized for its robustness and high predictive accuracy. The evaluation was then conducted on the regression result obtained from these three algorithms. And now let me present the details of the dataset we used. The data is sourced from Statewide Planning and Research Cooperative System, or SPARCS. It is fully compliant with HIPAA standard, as all privacy-sensitive information has been removed. The dataset consists of 1,000 records with a total of 21 variables assigned in the table. Among these, only 2 are numerical, with 1 serving as the target variable. The remaining 19 are categorical variables, which can be grouped into 3 categories: demographic features, facility utilization, and medical codes and diagnosis. And here are the encoding method we applied. We used three techniques: target encoding, ordinal encoding, and binary encoding, each selected based on the characteristic of the variables. Next, we carried out a feature selection to determine the variables that would serve as predictors of healthcare costs. This was done by calculating the Pearson correlation coefficient between each variable and the target variable. Variables with moderate to strong correlation were selected as predictors, while the rest were excluded. As the final stage, regression was performed using the tree algorithm mentioned earlier. For XGBoost and random forest, we applied 3 different hyperparameter scenarios, as can be seen in the display table. Here are the accuracy evaluation results from the tree algorithm. Both XGBoost and random forest achieved strong performance, with the best result observed in scenario 2 of XGBoost. As shown in the table, their regression quality is significantly better than that of linear regression, with MAPE errors almost consistently below 1% and the lowest recorded at 0.68%. This result indicating that the predictions are highly accurate and effective in improving reimbursement estimates through the use of the APRDRG coding system. And here are some key points derived from this study. This study examined 20 variables that may serve as predictors of healthcare costs. From these, 13 were identified as significant contributors and selected as predictor for the medical expenditure regression analysis. The feature selection process highlighted the APRDRG code and CCS diagnosis code showed particularly strong correlation with healthcare costs, with coefficient exceeding 0.9. This underscores their reliability and effectiveness in predicting healthcare claims and reimbursement. In contrast, factors such as mortality risk and demographic variables, including ethnicity and gender, displayed low correlation with total charts, indicating that they play a limited role in influencing inpatient medical expenditure. The findings showed that incorporating additional claims data, such as demographic, diagnosis, and facility use, significantly improves the accuracy of cost prediction, with XGBoost and random forest delivering highly reliable results. This study is limited to inpatient costs, so future research should address post-treatment care, chronic condition, and multimorbidity. Moreover, since Indonesia used the INA-CBG system rather than APRDRG or CCS, further studies are needed to adapt and integrate this coding system for more accurate healthcare cost regression in Indonesia. That concludes our presentation. Thank you for your kind attention.